Hello everyone, my name is Tim, and today we're going to talk about a start component called a PTC, or Positive Temperature Coefficient Resistor. Positive temperature coefficient resistors mean that as the temperature goes up, so does the resistance. The opposite of that is an NTC, negative temperature coefficient, which on an NTC, as the temperature goes up, the resistance goes down. PTCs are used for, again, starting components for small compressors. As resistance goes up, current will go down, reducing the amount of available torque to a start winding. So as that PTC warms up, it's going to allow less current to flow to that start circuit and will basically de-energize that start circuit when the compressor is up and running. If I take a look at my pictorial behind me, we can see that we have our start components, which could be a thermostat, a contactor, whatever it happens to be. We have my common. So when I close these set of contacts, I'm going to energize my run winding, but the compressor will not start yet because it needs that offset current going through the rotor to give it a slight phase shift to get that motor going in the right direction. So we need our start winding. When this PTC, which we have here, is cold, I'm going to have very low resistance between what is, for all intents and purposes, the wiper and here, which the current will pass through here, and apply a lot of current to that start winding. It's very similar to this potentiometer. On my potentiometer, I'm manually turning this, and what I do is I have leads here, which represent these leads here. This wiper that represents here is this wiper represented here. When I go to start, I'm going to go, the current's going to pass through here, through the start winding, through here, to where there's very little resistance, basically going straight from here, through the wiper, and over here to my other lead to power up that start winding. As temperature starts to go up, what's happening is I'm starting to increase resistance, increase resistance, increase resistance. Now, my resistance is going from here, it's going up, up, up. Because look, I'm getting a greater distance away from here until it gets all the way over. Now, I've got a huge amount of resistance between here, all the way through these windings, to this point here, and out over here to my wiper, and down to here, to my start winding. So as that starts to go up, that resistance, the current is actually going to go down to the start winding until it, for all intents and purposes, kicks out the start winding. Other potentiometers like this do the same basic function, except instead of my hand turning the potentiometer, it's actually temperature that's doing it. We've studied in the past videos potential relays, current relays, easily identified by size and by the windings, and we look at PTCs. PTCs have two connections on them. One is where I connect to the run winding, and the other one is the start. And I'll have one or two leads on the back side. When the PTC is cold, the resistance between these 2 points, between the wire for the run winding comes in and the start, is very, very small. So if I look at my diagram, or my meter, we're going to see I'm on the ×1 scale. So I should read about 5 or 6 ohms on the scale. Very low resistance. If I open up a PTC, I will see those leads, and then we'll see the PTC in the middle. As that PTC warms up, the resistance between these 2 points is going to go up high enough so that it's going to basically de-energize the run winding. PTCs also come in kits. So for example, this is a starting kit. It's a 3-in-1. Easily identified as the incoming power leads. Then we have my start, run, and common leads. This is a start kit which incorporates the PTC, often called a 3-in-1, which I'll explain now. When I open this up, component number 1 is a start capacitor to give it that extra kick to get going. When I open it up, I also see I have a current relay, so that if it draws too much current, it opens up. And then I see my PTC. Because this is cold, I should be able to go across it. And I will see basically 4 to 6 ohms, or 6 to 7 ohms, or somewhere in that range, as you can see by the meter. Very low resistance, and again, my meter is on the R×1 scale. Now these PTC kits should not be confused with other kits that look very similar. These are called booster kits. This is simply a start capacitor that you can add across a normal run capacitor to get that unit, the extra torque it needs to get moving in case you had low voltage or some other issues with starting the compressor. Now if I look at the meter over here, what I'm going to be using today is this 3-in-1 start kit. So I have my 3-in-1 start kit here, and it's got the built-in potential relay. And what I'm going to quickly do is see that when we go to start this, we're going to actually have a lot of current going through that start winding. And what's going to happen is, as that current goes through there, it's going to get warmer and warmer in that PTC until it finally kicks out the start winding. So we can see there current's going through the PTC. It's going to go through the PTC until it reaches its predetermined temperature, higher resistance, and it's actually going to kick out the winding. So if we look back at our chart, we can see we have our run winding. Our run winding gets energized as soon as we close the set of contacts. The start winding is going to get energized at about the same time, as long as that PTC is cooled down. It is critical that we let that PTC cool down. Otherwise, the resistance is going to be too high and that compressor will not start. So if it's cooled down, resistance is going to go from the start winding through, equivalent to that wiper, down to that lowest resistance point, and back to give me my power to actually get this motor running. As it warms up, that PTC is going to start moving this way, just like my potentiometer did. It's going to start moving. In this case, based on temperature. Instead of my hand moving it, it's actual temperature moving it. Until it reaches a point where the resistance is really, really high, and I'm going between here, and through this set of windings, and it's way too high to enable that start winding to get the torque it needs to induce the current into the rotor. So that's PTCs, positive temperature coefficient resistors. I hope you've enjoyed this. If you have any other things that you'd like to see, please let us know. Tim out.